Hello, this is question number 3 from the problem book. So about page table entry in rowhammer. Suppose that the system runs process A controlled by the attacker and process B in addition to the operating system. The memory has 8 physical page frames, so page frame 0, 1, 2, 3 until 7, of which the ownership is shown in the diagram below. Right? So frame A is owned by process A, frame 1 owned by process B, etc. The page table maps A's address space to the physical memory indicated by the arrows. So this is the mapping of virtual address of A to the page frames. Suppose that utilizing a rowhammer attack, the attacker can alter one of A's page table entry. Okay, so obviously here A has multiple page table entries. Actually, these are the pages. The page table entries are the one that map to here. So, but we have as many as the number of pages. Okay. Now, the first question is list all the pages for which their PTE could be targeted for alteration. So, what page table? So what pages have page table entries that can be changed? Okay. So, if we look at, let's look at it one by one. So, page 0 is mapped by its page table entry to frame 0. Okay. So because it has a mapping, then it is a target for alteration, because if you have a valid mapping, you can change the mapping to point to something else. Okay. So this will include sorry, let's fix this. This includes page 0. And let's look at page 1. Page 1 does not have a valid mapping. So if we flip a bit in the page table entry, it may not point to anywhere. Okay. It may not be used either by process A. So therefore, it's not useful. And then page 2 is similar to page 0, right? Page 3 has valid mapping. 4 doesn't have. 5 has valid page mapping. Okay. So therefore, the answer for A is that the pages that could be, their PTEs can be targeted for alteration include 0, 2, 3, 5. Question B, list all the page frames that can be destination of the altered PTE if the attacker wants to read or write data of process B. Okay, so now the next thing is this. So once we identify what pages that PTA can be changed, the next question is what should it be changed to, or what should be one of them be changed to point to the target. Now remember that for process A, it can access any pages that has valid mapping because the operating system thinks those pages belong to process A. Okay, so it makes sense for process A to be able to use to access it to read or write, etc. Of course, it depends on other attributes, but in general, yes, it can read and write. Now, by changing the PTE, modifying the PTE so that it can point to other pages, then process A may be able to gain control of access to page frames that that is not supposed to. Okay, so in this case, in order to read write data of process B, we have to change one of the PTE to point to page frame 1. Okay, because page frame 1 has B. The next one is list all the pages that can be destination of the altered PTE if the attacker wants to read or write data of the operating system. Now the operating system has one page frame, this page frame 5. Okay, so if the if the A has a PTE that maps to page frame 5, then it can read and write to it. Okay, so therefore here the answer is page frame 5. All right, that's it.